Okay, so now in this video, we are going to look at the homework problems 43, 45, and then 53 and 55, or I believe 57. So anyway, so these problems relate to the equalities, okay, and the conversion factors. So if you look in your book, and also in your handout, I've given you these tables, okay? So you don't have to memorize them, but you should know how to use this information to do the conversions from one unit to another, okay? So that's the basis of the dimensional analysis. So anyways, as you can see, excuse me, the metric system is the standard system used, internationally. And so here they have the kilos, the kilo is like a larger unit, but milli is like a smaller unit. Okay, so so these are the units. We have them already explained in the chapters, and you can see these are the basic metric and the effects, the prefixes that they're using. So if you see the kilo, mega, giga, tera, peta, these are all big units. Big units means big measurements. The magnitude is big. And these can be applied to anything, to grams and to liters and to meters, those things. Okay, so whenever something is kilo, that means it's 10 to the power 3, like it's 1,000 times more. 10 to the power 6 is the mega. Giga is 10 to the power 9. And then 10 to the power 12 is tera, like terabytes, right? Gigabytes, megabytes. And peta is 10 to the power 15, like huge, huge amount. And like I said, you can apply it to grams, you can apply to seconds, you can apply to meters, you can apply to liters, milliliters, distances, so those things. So anyway, so here we have this larger unit, but then at the same times, we also have smaller amounts also that are measured. So for them, the prefixes used are deci, centi, milli, micro, nano, pico, femto. Okay. So deci is 1/10. So in other words, 10 to the power 1 or 0.1. Centi relates to really small, even smaller than deci, and that is 0.01. So 2 places after the decimal, and that is 100th, and that is 10 to the power -2. Okay, then you have milli. Milli is 0.001, and that is 1,000th. Thousandths, right? And that's the sound. So it's 10 to the power -3. And then comes the micro, which is 10 to the power -6, nano 10 to the power -9, pico 10 to the power -12, and femto 10 to the power -15. So like really small amounts, like picomolar, like really, really small amount. Picomolar is like molarity. So molarity, but very, very, very small. So I worked in drug discovery where, teeny bit of, compound was a small molecule was very potent. So that's where for the potency of the drug molecules, they use those terms. So anyway, so you can still apply them in seconds, you can apply them in meters, you can apply them in liters, and those things. So grams. So here we have, as you can see, deciliters, like smaller than smaller unit, then centimeters, like smaller, then seconds, microseconds, those things, or micrograms or milligrams, right? And then the seconds, also picoseconds, really small, and femto is even small. So these prefixes give a definition to the unit, in what context we are measuring things, and like what is the magnitude of that measurements, whether it's very small or whether it's very large, and how large it is. Besides that, they are also related to each other. So kilometers and meters are related, meters and millimeters, centimeters and millimeters. So you can see these relationships, and also you see these units. So the units, whenever you use like meters, centimeters, millimeters, that means you are measuring the length. When you're using milliliters, deciliters, liters, centimeter cubes, then that means you're using the volume. Okay, you're measuring the volume. The mass especially is grams, kilograms, micrograms, milligrams, right? And tons, all those things. So that is the mass, the amount of weight, okay? So that's, and then time is obviously hours, second, minutes, those things. But in US, we use different types of, units, and that is the feet, right? Inches, feet, yard, and these are also related. So feet and inches are related as 1 feet is equal to 12 inches, 1 yard is 3 feet, 1 mile is 5280 feet, 1 quart is 4 cups. You see that? So all these are called the equalities, even with the units that we use in United States. Okay, so that's one piece. Now, next is when we are doing things on an international scale, we need to have some uniformity in the measurement. And that means that we are coming up with some system where the metric system and the US system can be equalized, or they can be like interconverted. Okay, so here you have the metric system and the US system. For example, the centimeter and inches. So 2.54 centimeter is equal to 1 inch. Right? So that's the equality. And then 1 meter is 39.4 inches, 1 kilometer is 0.621 miles, all those, equality. So you will be using these tables as a reference to do the problems, the conversions from one unit to another unit. Okay. All right. So now let's look at these problems. So writing the conversion factor. Okay. So we know whenever we write these fractions, the numerator is on the top, the denominator is on the bottom. The numerator, the top one is, and you can switch also, depending. So you can, like, 60 minutes per hour can also be written as 1 hour over 60 minutes. So if you have an equality, 60 minutes is equal to 1 hour, or 1 hour is equal to 60 minutes, then the two conversion factors of this are 60 minutes over 1 hour, or 1 hour over 60 minutes. And later on, we are going to look at, using these conversion factors to find the unknown, or to convert between the units. Okay, so let's do the homework problems. Okay, so as I said earlier also, then I'm not going to be doing all the problems. I'll only do a few from every question, and then the rest of it you do on your own. And it's also a good idea that you do these problems with me as I'm showing you. But pretty much, you should also do on your own. The answers are already given. Okay, so here, write the equality, problem number 2043. Here, write the equality and the conversion factors for each of the following pairs of units. So centimeters and meters, how are they related? Liters and milliliters, how are they? So you're going to write down the equality. Now, equality, obviously, I'm not expecting you to memorize, so refer to the table. So centimeters and meters. So let's look at the table. Centimeters and meters, so length. So here, you are not given the direct relationship, centimeters and meters. Direct relationship is not given. So sometimes you might have to do the Google, or you will have to do a two-step. But for simplicity, I'm going to just let you know that you can also do it on the Google. Convert or equality between centimeters and meters. So let's look at that. Okay, so 1 meter is 100 centimeter. Okay, so centi is 100. So here we have, this is the equality for the first question. So here, how are we going to write the conversion factor? So very simple, 1 meter over 100 centimeters, or 100 centimeters over 1 meter. Okay, so these are the two conversion factors. Let's look at the next part also. Just give me 1 minute. Okay, so here, according to the table, the next part is you convert, liters and milliliters. How are they related? Or milliliters and liters. So 1 liter is equal to 1,000 milliliters, or 1,000 milliliters is equal to 1 liter. So here, let's look at the problem. I think it's problem C, 43. 1 second. So I think it's 43 part C. Okay, here is 43 part C, liters and milliliters. Okay. Okay, so C, and that is, the question is, The question is the relationship, right? The equality and the conversion factors of liters and milliliters. So from the table, we see that 1 liter is equal to 1000 milliliters. Okay, 1 liter is 1000 milliliters. So write down the equality and then write down the conversion factor. 1 liter about 1000 milliliter, or 1000 milliliters over 1 liter. So these are the conversion factors. Equality, and the next is the conversion factor. Very important. Now, in general, I'm going to just EQ, short form symbols, EQ, and here conversion factor, I'm going to put as CF. Okay, just for like short forms. Okay, next problem is problem number 47. Let's look at that. Okay, so the next question is 2.47, and here we have to create the equalities based on either the sentence, what is there in the sentence, or from the formulas, those things. So here we are given a problem in A bee flies at an average speed of 3.5 miles per second, or meters per second. So 3.5 meters per second is the equality. So let's write this down. So part A is 3.5 meters per second. So the way this thing can be written is 3.5 meters is equal to 1 second. Okay. And then the conversion factor becomes 3.5 meters, 3.5 meters over 1 second, or 1 second over 3.5 meters. Two conversion factors. Now, the next question was, tell whether the numbers are exact. So yeah, the number 1 is the exact number, right? That is the exact number, but 3.5 is not an exact number. 3.5 has 2 significant figures. All right, so this is how you are going to do the rest of the problems in this question. But I'm going to move ahead to the next problems, which is the problem number. So we completed these 43 and 47. We are going to look at 53 and 55. Okay, so 53 and 55 also come from the, are the conversion factor problems. So 53 and 55. So your problem here, 53. All right, here is the 53 problem. All right, here, 51 is here, 51. Okay, use the metric conversion factors to solve each of the following problems. So you are given the height of a student, 175 centimeter. How tall is the student in meters? So let's write this down. Problem number 53, the height is given and you need to find in meters. 175, I forgot again, sorry. 175 centimeter to meters. 175 centimeters, and you need to convert that to meters. So what will you do? So in this case, in this problem, you are going to look at the relationship between how many meters and centimeters are, related. So we know that 1 meter is equal to 100 centimeters, right? And in case you do not know, with practice, you kind of memorize it. But in case you do not know, you can always check. Okay, so always check the equality. So here, 1 meter is 100 centimeter. If some of the equalities are missing from the handout, which are obviously taken from the book, then please feel free to put your own equalities on the reference table. All right, now, This is, first of all, remember, the setup is first you write down the given, whatever is given to you, you multiply that by the conversion factor. The conversion factor, the unit that you want is going to be on the top in the numerator, and the unit that you want to remove is going to be in the denominator. So the unit that you want is the unit, in this case, centimeter is being converted to meter. So we want to have the meters on the top in the numerator, NUMERATOR. And the unit that is given to us and that we want to cancel out, so given unit is centimeter. So that is what, you have to look at the equality in which the centimeters, they get canceled out. So denominator matches the unit in the denominator, match with the units that are given to you. Okay, so you are given centimeter. So you're going to put the unit, when you do the conversion factor, centimeter will go in the denominator. And the meter is the one that you want to find out. Okay, so here we see, first of all, 1 meter is equal to 100 centimeter. So the two conversion factors are 1 meter over 100 centimeter, or 100 centimeter over 1 meter. Okay, so now out of these two conversion factors, which one will you use? Because we want to find out how many meters, so we are going to have this one, this conversion factor, because that allows us to cancel the centimeter. So now you write down here 175 centimeter, that is given to us. Multiply that by that conversion factor that places the meters in the numerator and the centimeters in the denominator, so that the centimeters can cancel out. So we see that this centimeter and this centimeter cancels out. And now you are left with 175 times 1 divided by 100. And so this gives us the answer 1.75. And put the unit, always leave the units, 1.75 meters. Okay, so technically, if we are looking at like how many places after the decimal, or how many significant figures, if you look at it, these are 3 significant figures, 3 significant figures. So this is 3 significant also. I mean, if you were absolutely need to have it in the like the lowest, this is like, whenever they're the exact numbers, so it's the variable significant figures. So here you will see the 1.75 is giving you 3 significant figures, a more sensitive data. Okay, all right, so that's the number 53. Now let's look at, and similarly you will do the other ones. I'm going to leave the other questions for you to do, but this was 53A. Okay, now the next question is 55. Okay, so 55 is, let's look at 55. Sorry, 55. All right, here we have problem number 55. Okay, here, solve each of the following problems using one or more conversion factors. So in other words, we are going to look at like multi-step. Okay, so because there's no direct conversions like in the previous case you saw. So here we are looking at the first example I'll do, and then you do yeah, the remaining you should do on your own, because I want you to do the remaining on your own, but if you can, then I'll help you with those also. Anyway, so let's look at this one. Let's do part B, 2.55, part B. What is the mass in kilograms of a person who weighs 175 pounds? Mass in kilograms and 175 pounds. Let me write this down. Okay, B. Okay, so you are given 175 pounds, and you need to convert it into the kilograms. So 175 pounds, 175 pounds, convert that to kilograms. And is there a direct relationship between the pounds and the kilograms? No. So first convert the pounds to some common unit, and in this case grams, and then convert the grams to kilograms. Now let's look at the tables where we are going to find the equality, then we create the conversion factors. So let's look at the relationship between the pounds, grams, and kilograms. So go back, look at the table, and these tables, as I said, are also in your handout. So on the exam, you can use the, I'm not going to give you the equality. You should know where to look for the data. Okay, I'm not going to spoon feed you with like giving you all these, but once the table is given to you, you should know how to use that information. All right, so sorry about that. All right, so here is the table, the same table that we are using, table 2.7. So, okay, so pounds and mass. So there's a relationship, grams, kilograms to pounds. Okay, luckily you're given kilograms to pounds, a direct relationship is given, and grams and 1 pound. But let's say there is no direct relationship, just assume. Okay, 454 grams is 1 pound. So let's put this here. 454 grams is equal to 1 pound. So this is one thing note. And 1 kilogram is equal to 1000 grams. This is another thing that is known from those tables. Okay, so let's do this. So here the conversion factors are 454 grams over 1 pound, and 1 pound over 454 grams. The other one is 1 kilogram over 1000 grams, or 1000 grams over 1 kilogram. All right, so this is given to you in the tables, so you can use it on the internet or those things. So anyway, so here we have now 175 pounds, write that down, 175 pounds given. So you need to get rid of the pounds first and convert them to grams. So obviously from here, you're going to use this 454 grams over 1 pounds. Okay, so that gets rid of the pounds. Next, you can go from here straight in one line. We're going to convert the grams to kilograms. So we know that 1000 grams is equal to 1 kilogram. Our final unit that we want is the kilograms, right? And the rest of them have to all cancel out. So you see grams, pounds and pounds cancel out, grams and grams cancel out. So in other words, we have converted the pounds to kilograms by this method. Okay, so next is, now all of them are exact numbers, right? So let us see what we get the answer. Hold on. Okay. Okay, so when you do this calculation, you get this data from the, you get these numbers. And so when you multiply this becomes, when you divide and multiply, then when you solve it, this becomes 7.94. Okay, 7.94. And that is 7.94. Sorry, not 7.94. It's 79.45. Sorry, my mistake here, 79.45. Okay, now, 79.45, 4 significant figures. It seems like, 2 places after the decimal, or that it's like a little bit more exact. So leave it as that. So here, the only thing you need to write down is the final. So this was in kilograms. So this is the answer, because all the numbers here are the exact numbers. So I'm not saying that here, like generally as a rule of a thumb in chemistry, 2 places after the decimal are like kind of standard. So leave it at that. If the question is not asking you for the significant figures. Okay, let me do one more question here, which I think, you might benefit. And that is the next question. Where did it go? hold on. Why is it showing that? Okay, here. All right, now we are looking at the next question, which is five, like the next part of it, which I think we should benefit. Okay, let's do this one. C, an athlete. Okay, let's do the next part, the percentage. An athlete has 15% body fat by mass. Now remember that 15%, this can also be used in the conversion factor. What is the weight of the fat in pounds of a 74 kilogram athlete? So let's write this problem down. Okay, so here we have written the problem. We are given the weight of the athlete is 74 kilograms, and then the fat is 15% fat by mass. So what is the weight of the fat in pounds? So that's the problem. Okay, so a few things here. First of all, 15%. 15% fat by mass. What is the meaning of this? This means that 15 grams of fat is present in 100 grams of the body mass, right? Of the body weight or the total body mass. Okay. Now the percentage, the beauty of the percentages, we can apply to, any other unit also. So you can also write down 15 kilograms of fat is present in 100 kilograms of the body mass. Okay, and the same thing you can also convert to 15 pounds of fat is present in 100 pounds of body mass. Okay, so here you see the, percentages can be applied even to liters, milliliters, and all those things. So in this case, let's just keep that. So these are just some examples, okay? The next thing is, this is one piece. The next thing is, from the tables, we can get that what is the relationship between the pounds and kilograms, because they're asking us what is the weight in pounds, weight of fat in pounds. So we need that. So here we see that 2.20 pounds is equal to 1 kilogram. So that is from the tables, from the reference tables. So 2.20 pounds is equal to 1 kilogram. And using that, you can create the conversion factors. 2.20 pounds over 1 kilogram, right? And the other thing is that 1 kilogram over 2.20 pounds. Okay, so these are the conversion factors. Now let's do the conversion. So where are we going to start? Always, you kind of develop that like this is a conversion factor, but this is something that needs to be converted to. So we need to get rid of the kilograms. That's the total weight. That is the body mass. This is the body mass. And in that body mass, how much is the fat, first of all? And then what is the weight of that fat in pounds? So what is the strategy here? So you are going to write down the known, which is 74 kilograms. Okay, first convert the kilograms, that is the body weight, body mass. So we need to get rid of the body mass, and we need to find, convert that first to the mass of the fat. Okay, convert the fat mass into the in this case, you will be given the kilograms of the body mass, like 74 kilograms, and then you convert that to the fat in kilograms. So let me just put this here. Kilograms of, how many kilograms of fat is there? And then convert that kilogram of fat to the pounds, and that is of fat. Okay, so That's how you will do this calculation. Okay, so let's write this down. 74 kilograms body mass multiply by the percentage, right? And that percentage actually gives us the way we can get rid of the body mass. So we know that in the percentage, 15 kilograms is the fat and 100 kilograms is the body mass. So you see here, diagonally, you can cancel out the kilograms. Now you're just left with the kilograms of fat. Next thing is, we know that 1 kilogram is equal to 2.20 pounds. So that is what you need. And 1 kilogram is in the denominator. So that's the equality and the conversion factor that is already known from the table. Okay, so body mass cancels out. You're only left with the fat now. Kilograms and kilograms cancel out. Kilograms of fat and kilograms of fat cancel out. So we only need in the answer the fat in pounds. And that's how you get that. Sorry, not the fats, but fat. Okay, now write down 74 times 15 times 2.20, divided that by 100 times 1. And here you are obviously looking at these exact numbers, 1 exact number, 3 exact numbers, and 2 exact numbers. So what we are going to keep every time you have a decimal number, that takes the priority, because remember the exact numbers have variable significant figures. So here this is the priority. So these are the 3 significant figures. 3 significant figures. Okay, so your answer should also have 3 significant figures. So let's calculate this, and you are going to get the answer equal to, let's see, let me do the calculations. Okay, guys, so here, when you multiply and divide, you get the answer like 2442 divided by 100, and that's 24.42. Now, what should be the answer? Ideally, 3 significant figures, right? Exact numbers are like, not included if there is a decimal point, and then in that case. So ideally, it should be 3 significant figures. So you have 1, 2, and 3. And because 2 is less than 5, therefore 4 remains as is. Okay, so 4 is as is. So therefore this answer is, so 4 is as is. So here you will see the answer can also be written as 24.4 pounds. Okay, that's the ideal one. But your book is giving you 2 significant figures. So they're dropping off like the 4 and 2 completely, which might be okay, kind of okay. But if the question is very specifically mentioning significant figures, so always follow in this case the rule that the decimal numbers, they always take the precedence. And in chemistry, it's always good idea to be more precise when it comes to the places after the decimal. We want to keep as much uncertainty or ambiguity out of the way. So 2 or 3 places after the decimal is more sensitive. Okay, all right, so that finishes this part. Now we are going to look at the next 2 questions. We finished 53 and 55, 63 and 65 in the next video. Okay, all right.